Hey guys, welcome back to part 2 of my Godot VehicleBody tutorial. What we'll be going over today is implementing projectiles as well as implementing forces once the projectiles make contact. So first and foremost, what we're going to do is we're going to go to our project settings and we're going to input two new input maps. The first one is going to be RMB for right mouse button, and then the second one is going to be LMB for left mouse button. So these are the two things we're going to be using for aiming and shooting our weapon. So just click on the plus sign and add it just like that. First and foremost, what we're going to do is go to our Humber scene and go to our gun mesh. What we need to do is we'll need to add a position 3D, which is going to be our muzzle, i.e. the position where our projectiles are going to spawn from. So once we've implemented as a child, what we're going to do is move it forward just so it's at the tip of the gun mesh, just like that, and rename it to muzzle. What we're going to do now is open up our Humber script and we're going to use the function integrate forces. So like I said before, integrate forces is the function that we use when it comes to transformations and applying forces. Because we're going to be using it to rotate our turret, this is exactly the function that we're going to be using. So our line of code is going to be if input does is action pressed RMB turrent dot rotation dot y is equal to lerp angle turrent dot rotation dot y, and we're going to be lerping it in direction of our camera. So what that means is basically as our camera is looking around, once we use the aim button, it's going to align to whatever our camera is looking at. So to do that, we get our camera dot rotation dot y, and we're going to be doing it at a speed of 0.02. After that, now that we've got the turret moving sideways, what we want to do as well is have our gun point upwards and downwards. The only issue behind this, if you can see, if you point downwards too low, the gun will start clipping with the mesh. So to avoid this, what we're going to be doing is we'll be adding a clamp to our rotation degrees. So as you can see, 15 is too far. So what we'll be doing is -10 and our max value to be 30. So let's go back to our script. Let's go to our turret slash gun dot rotation dot x is equal to lerp angle turret dot gun dot rotation dot x, and we'll lerp it to our camera dot rotation dot x at a speed of 0.02, followed by a clamp dot rotation dot x is equal to clamp turret gun dot rotation dot x, and we'll be using the dead to rag function again to convert our degrees to radians, and just like that. So if we run the script right now, we'll see how it looks like. And as you can see, our controls work as normal. We can move about, we can brake, our camera works just fine. But this time when we press our aim button, our turret will look in the direction of our camera, and if we look up, our gun will point upwards, and if we look down, our gun will point downwards. And that is exactly what we want. The second thing we're going to do is we're going to implement a slight zoom when we're aiming. So as you can see, if we go back to our camera node, you'll see that the spring length is 5, meaning that once the project starts, our camera will move back 5 units. So to implement the zoom, what we need to do is just to reduce this number. So to do that, we'll enter our script again. We're going to reference our camera itself, dot spring arm, spring length is equal to lerp, camera dot spring length, and we'll change it to the value of 3 at the speed of 0.1, and this time we'll be adding an else function, meaning that once we let go of the aim, we want our camera spring length to return to the value of 5. Once that's done, if we run the script again, you'll see the change. As you can see, once we aim, the camera will zoom in slightly, and once we let go, it'll return back to normal. Just like that. Now that everything's set up, we can start working on making the projectile. So first things first, what we're going to do is we're going to open up a new scene. We're going to press the plus sign and add a area node as our root node. So after that, what we're going to do is we're going to change the name from area to rocket. And basically what we're going to be doing is we're going to be shooting out a hitbox. So we're going to be adding a collision shape. The collision shape is going to be a capsule. The radius is going to be 0.1 and the height is going to be 2. Then we're going to be adding a mesh with the same values. Capsule mesh with a radius of 0.1 and a mid height of 2. The second thing we're going to be doing is we're going to be adding another area node. The reason being, this is going to be our blast radius. So this is going to be the area of once the rocket comes in contact with something, it's going to check the surrounding area to see if there are any rigid bodies that can be affected by forces. So we're going to rename this to explosion, and we're going to add a collision shape, which is going to be a sphere with the radius of 10. The only major difference that we need to make right now is we need to click on the explosion area, and where it says monitoring, we need to uncheck that, because what we want to do, we want to make sure that the rocket makes contact first before it starts checking the area around it. So after that's made, what we're going to do is we're going to right click on the rocket area and we're going to attach a script, rocket GD. Because this is an area node, it's not affected by things like velocity or forces. So what we're going to do, we're going to use function physics process, and we're going to affect its translation directly. So its translation is going to be minus equals get transform dot basis dot z, which is going to be, if we go here, the z-axis is forward and back. So by using the transform basis, we're getting its rotation and its z-axis relative towards its rotation. So negative meaning that it's going to be going forward at a speed of 50 per physics step. The second thing we're going to be doing is we're going to be adding a signal. So click on the rocket again, but this time go to node and click on body entered. Right click and connect it to your rocket script. What this is going to be doing is once a body has entered this area, it's going to be using the following code. So if body.getClass is equal to rigid body, or body.getClass is equal to static body, explosion.monitoring is equal to true. Basically what this means, once the rocket has come in contact with something, if the thing that it's come in contact with is a rigid body or a static body, make the explosion happen. So the second thing we need to do now is add a second signal. So click on the explosion area, right click and connect the body entered, and we're going to be using the following script. Var bodies is equal to explosion.get overlapping bodies. And then we're going to be using a for loop. So for body in bodies, if body.getClass is equal to rigid body, body.applyImpulse vector 0, vector 3.0, brackets, body.global transform dot basis minus global transform, global transform dot origin minus global transform dot origin dot normalized times 10 and after that, Q free. So basically what this code means, once the explosion goes off, it's going to be checking the overlapping bodies in the area. And if those bodies are rigid bodies, we're going to be applying an impulse to the center of those bodies relative to where they are in comparison to the explosion itself with a speed of 10. After that's happened, the missile itself is going to remove itself from the scene. And then that's it. So we can save this actually. Save this as a rocket.tscn, and now we can go back to our Hummer and go to the scripts and focus on implementing that as a projectile. So before we do that, we're just going to clean up our code a little bit. The first thing we're going to do is add a few comments. So this is going to be our vehicle's variables, and then we're going to add a new comment called weapon variables, and we're going to use two onReady vars. The first one is going to be muzzle, which is equal to getNode, quotation marks, and then we'll get the node path and put it into the quotation marks. And the second thing we're going to do is rocket SCN is equal to preload, quotation marks, right click the rocket.tscn, get the path, and paste it in just like that. So the reason why we're using preload is because since the rocket.tscn isn't part of this scene, we want to be able to preload it so we can use it in our script. So the other two variables that we're going to be using are fire rate, which is going to equal to 1, and then can fire, which is going to equal to true. After this is said and done, what we're going to do is we're going to scroll down and we're going to make a little space here and add a comment for shoot weapon. So what we're going to do is if input dot is action just pressed, or is action pressed, sorry, LMB, if can fire is equal to true, what we're going to do is var rocket is equal to rocket scn dot instance. Then we're going to add that instance to our muzzle as a child, and then we're going to rocket.set as top level is equal to true, and then set our can fire to false. So what this basically means is once we press our left mouse button to shoot our weapon, if we can fire it, then we create an instance, create it at the point of the muzzle, and then separate it as a child so it's an independent node and it can go off and do its script, meaning go forward without any influence from the muzzle itself. And then we can set our fire to false so we're not shooting every step. After that, what we're going to do, we're going to use a yield function, get tree dot create timer based on our fire rate as a timeout. Once that is done, it will set our can fire back to true. So what this means is after we've fired our weapon, because we don't want it to be firing every step, we set a timer to delay our next fire by our fire rate before it sets it back to true so we can fire again. So if everything's working, let's test out the scene and see how it looks. So as you can see, I can aim in any direction, I can click the button, my projectile goes off in the direction it's facing, and it's not affected by the muzzle after it's been fired. If I want to increase the delay between shots, I would just merely increase the fire rate or reduce the fire rate if I want to make it a bit faster. So the very last thing I want to do is I just want to implement some targets so we can see the explosion in effect. So go to your world, create a child, which is going to be a rigid body, create a collision shape, which is going to be a cylinder, add a mesh, which is also going to be a cylinder. And what we're going to do, bring it up, bring it out, and then Control D to duplicate. Move it here, duplicate it again, and again, and again. After that, what we're going to do is highlight all the rigid bodies that we created, duplicate that, move it out to the side, rotate it, duplicate it again, out to the side, rotate it, and then let's test it out. So if everything's been coded correctly, if I take a shot at one of these barrel piles, they should explode. Just like that. And that's pretty much it. In my next video, I'll probably be adding a particle system, add some particles to the explosion, maybe some dust particles at the back of my car for when I'm drifting. But other than that, feel free to comment, leave a suggestion, and if you like what you see, feel free to subscribe. Thank you so much for watching, and I hope you have a great day.